All right. This will be example problem 2. So last time we did an angle of depression. That one was pretty tough. This one's an angle of elevation. And really, once you get the picture drawn, it's pretty straightforward. It's one triangle, pretty much a one-step problem. So the key is just making sure that we set it up properly. So let's read the problem and figure out what we need to use for the problem. So the world's tallest unsupported flagpole is a 282-foot tall steel pole in Surrey, British Columbia. The shortest shadow cast by the pole during the year is 137 feet long. What is the angle of elevation of the sun when the shortest shadow is cast? Right. So if you think about, I'm sure you've seen tree shadows, right? They'll get longer or shorter throughout the day, depending on how high the sun is in the sky, right? And so the higher the sun is, the shorter that shadow is because it's kind of coming down kind of on top of the tree, right? And so that's the idea here is how tall or what angle is the sun at, such that, it creates the shortest shadow that you're going to see. And so, that's going to change based on where you are in the world, but in this particular location, our goal is to figure out what that angle is, right? So important information in the problem. 1, our flagpole, the true height is 282 foot tall. And the second piece of information that we have is that our shortest shadow is 137 feet long, and our goal is to find the angle of elevation of the sun. So we shouldn't be getting a length, we should be getting an angle, a degree measure, right? So we can kind of base whether our answer makes sense on whether we're actually getting an angle measure or not. If we get a side length, then we've probably gone about this the wrong way, okay? So let's start to draw a picture. So the flagpole is that's my flagpole, 282 feet tall. And its shadow is a little bit more than half that at 137 feet long. So that's the flagpole shadow. And then up here, we've got the sun. And its light's coming down through the pole and causing it to build a shadow. And so what we want to find is this angle measure right here that tells us the angle that the sun is hitting that pole at, right? So let's kind of take stock of what we have and what we need to find. So I'm trying to find an angle, right? So I'm probably going to use inverse trig. And so to go about doing that, I want to figure out what I have in the problem. So I'm looking for the question mark angle. So let's label our sides based on that. Well, the first side we'll look at is 282 feet long, and it's on the opposite side of the triangle. So it's going to be the opposite. The hypotenuse is the length between the top of the flagpole and the top of the flagpole shadow. That's kind of the path of the sun's light or lack thereof it, if you consider what a shadow is, right? So our other side, our 137-foot side, is going to be our adjacent side. And so if I have the opposite and I have the adjacent, then what I care about is tangent. I can't use sine because I don't have a hypotenuse. I can't use cosine because I don't have a hypotenuse. Tangent is the only thing that relates the opposite and the adjacent sides. So let's start to write out what we have. Well, I've got the tangent of some angle that I don't know yet. And I know that that's equal to the opposite, which is 282 feet over the adjacent, which is 137 feet. right? Oh, if I forgot to write the 7. All right. Now you'll recall that if I take the inverse trig of both sides on the left side, that'll cancel out my tangent, and I'll just be left with that side that I'm trying, or the angle that I'm trying to find. And on the right, I'll be taking the inverse tangent of the ratio between the two sides. So that's 282 feet over 137. And so I'm going to Desmos or to my calculator, and I'm plugging in the inverse tangent of 282 over 137. So make sure you're doing inverse tangent, not regular tangent. So you may have to hit the second button, or make sure that you're selecting tangent raised to the -1. That's what it looks like, though we say inverse tangent. And I take inverse tangent of 282 divided by 137, and I get that my angle was 64.09 degrees, and I'm going to chop that off and just call it 64 degrees. So that's my angle of elevation of the sun. So when that shortest shadow is being cast, the maximum height that sun is coming in at is 64 degrees. So really, once we got the triangle built, it was a pretty simple trig problem. The key is just remembering, okay, well, an angle of elevation is going up, and it's the angle at that bottom side of the triangle that's not the right angle. So it's important to be able to distinguish between the two, and once we did that, we were able to figure out what the angle of elevation to the sun was. So if you have any additional questions, would like any more examples, please send me an email, and I will make another one. So hope this helps. Hope you guys have a good weekend, and see you later.